All right, so today we're talking about substitution. Here we have a system. It's got a quadratic equation up top and a linear equation below it. So I know that I have possibility of having two solutions to my system, and I know that somewhere in the solving I will likely have to factor. So we're making a video because the factoring process takes a while and we want to watch that on the video. Looking at my equation, it's the second one is already solved for x, but if I plug that in, you can, but you'd have to plug it in multiple places and you'd have to FOIL. So my solution for this is to, in the second equation, to add the 2 and solve for the y instead of the x. So that's the first step, always solve for a variable in one of your equations. So I solve for the y, and I need to take that and replace the y in the other equation with that expression. So 3x squared minus everything that down here x or y was, which was x plus 2, equals negative 6x minus 4. So I have substituted. Now I need to solve this by simplifying it, distributing, combining, and factoring. I need to distribute this negative sign that was out front, so it's going to be 3x squared minus x minus 2 equals negative 6x minus 4. And now at this point, I know that I have x squareds and I have x's. What that tells me is that I am going to have to factor to solve it. And whenever you factor to solve, you want to bring everything onto the same side of the equation, and you want a 0 on the other side. You want the coefficient on your x squared to be positive. It currently is, so what I know is I'm going to bring everything over to the side that it currently is on. So I'm going to add 6x to both sides and add 4 to move those over. So I already had x's and constants on the left side, so I'm going to be putting those together. So the first thing, 3x squared stays the same. These will combine to be positive 5x. These will combine to be positive 2. And then everything cancels on the other side so that the right side ends up being 0. And this is the point where we are making the video for, because we have a coefficient on our x squared other than 1. So we had talked about different ways to solve this. You can guess and check with factoring, which I do not like. You can use the my father drives a red Mercedes or whatever method you have to remember those letters that stand for first multiply, factor, divide, reduce, move. This will work every time as long as this is factorable. The first step is to be a temporary fix to having the coefficient on the x squared. You're going to multiply that by the constant on the end. So it's going to be x squared plus 5x plus 6. And I know that that step always feels illegal when you do that, but it works out because of this process. We will correct for that at the end. Second step is to factor what you have in the first step, in that multiply step. Now I do not have any coefficient. The coefficient's 1 on the lead coefficient there, so x and x, and then a positive 6 at the end. So I need to think about factors of 6 like 2 and 3, 1 and 6. It's positive, so you want the same sign. You could also have negative 2, negative 3, negative 1, negative 6. Now I need to look at the middle term. The middle term is a positive 5, so what that tells me is that my factors need to combine to be a positive 5. I'm going to show you what my options really are. So I have 4 options here that would give me that middle term. I could get a 5, a 7, a negative 5, a negative 7. Since I want a positive 5 in the middle, I need to use these factors of 2 and 3. So I'm going to write plus 2 and plus 3, and that's the factoring step. Now we have factored it. We have to fix for the first step where we multiplied. This is where we're correcting for that. The D stands for divide. You will divide the constants on the end of each by the number you originally multiplied by, which was the 3. So I'm going to write this as x plus 2 over 3, and then x plus 3 over 3. R stands for reduce. You want to reduce either of these fractions if at all possible. So it's going to be x plus 2/3 and then x plus 1. And the last step, M for multiply. Anytime you still have a denominator, like this first set here has a denominator, M stands for move. You will move that denominator into the front of the parentheses there, so it will be 3x plus 2 inside the parentheses, and then x plus 1. And that is the factoring of it. But we're not done because we're solving a system. And what this means is that we need to find our x's and then plug in and find our y's. So I'm going to look back up top just to show you it was equal to 0. So essentially these factors are equal to 0. So I'm going to set each factor equal to 0. 3x plus 2 equals 0. And then x plus 1 equals 0. So subtract the 2 here, 3x, negative 2. Divide by 3, negative 2/3 for that one. Subtract the 1 here, x equals negative 1. Those are my two x values. And I feel like we should be done, but remember that those are points. So that's the first part of it. We have one last step for this, and it's the easy step. We need to find our y's. To find our y's, we need to go back to our equations. We can use any of the original equations or the one that we solved. I'm going to use this one right here where we had solved for y. Y equals x plus 2. So I'm using it, and I'll write it off to the side here. Y equals x plus 2 is the equation that I'm using. So I need to take this negative 2/3 and I need to add 2 to it. Basically 2 minus 2/3 is 1 1/3. That's the first y. And then for the second one, we want to plug in that negative 1 plus 2 would give me 1. So that y value is 1. And this is our solution to the system.